So today we will talk about combination and then my favorite topic, combinatorial arguments. Last time we talked about permutation. If you don't remember, we talked about permutation of multiset. Let's say you have a set S consists of n elements. They might be all distinct, but they don't have to be. They can have like elements that are identical as well. And I have k types. Let's say type 1, you got n1 elements. Type 2, you have n2 elements. Up to type k, you have nk elements. So if you think about it, this is your set S. And the cardinality of S is n. And you partition S into many different types. Type 1 has n1 elements. Type 2 has n2 elements. Type 3 has n3 elements. And up to type k has nk elements. Then if you take the cardinality of each piece and adding them together, it will give you the cardinality of the whole circle. So here you have n1 plus n2 plus up to nk will be equal to n. And we say that the number of ways that you can arrange element in S is n factorial divided by n1 factorial, n2 factorial, up to nk factorial, like this. So how does it relate to combination? Let's say you have 3 shapes. And you want to count how many combination of 2 shapes that you can form out of those 3. Let's say you choose the star and the triangle. It's the same combination as the triangle and the star, right? Because when you think of combination, order does not matter. So you can think of process of choosing 2 elements out of 3 elements like this. First, you can count the number of ways to do that is 3 choose 2. There are 3 choose 2 ways to choose 2 objects out of 3 objects. However, another way you can think of it is assigning the labels. C stand for chosen, N stand for not chosen. So what does it mean if I have the combination of the star and the triangle? It means that I assign chosen to the star and I chosen triangle, but I did not choose the square. You will see that the number of combination of 2 that you can form out of these 3 is the same as the number of ways you can arrange these characters. And here you have 3 characters, right? You have 3 characters. Out of those, you have 2 C and 1 N, which means the number of ways you can arrange them is 3 factorial divided by 2 factorial times 1 factorial. And they are equal. This is why you have the formula for combination. In general, you have n choose k is equal to n factorial divided by k factorial times n minus k factorial. because you have chosen, chosen, chosen k times, and then you have not chosen, not chosen, not chosen n minus k times. So the number of ways to arrange this sequence is you have n characters in total. Out of those, k letters belong to one group, n minus k letters belong to another group. So that's why you have this definition. Does this make sense? Next one, we will talk about very famous. I don't know another word for it, but like you have something like n choose k is equal to n choose n minus k. You can show this algebraically that the equality is true. You can definitely show that. Use this formula for the expression here, and also use this formula for the expression here, and then expand them out. You will see that two expressions are equal. However, you can argue for it in a more intuitive way, which we call combinatorial argument. So if you think about this, I have 5 balls. And I want to choose two out of 5 balls to give to my friend. Let's say I choose the 2 green balls to give to my friend. Then that action that I say, okay, I choose this green ball and this green ball to give to my friend is the same thing as I'm saying, I choose the 3 red ball to not give to my friend. So they are equivalent action. So you will see that 5 choose 2. The number of ways to choose 2 balls out of 5 to give to your friend is the same as the number of ways to choose 3 balls out of 5 to not give to your friend. They are equivalent action. So you can use the same argument. From this one, you can generalize up to like n balls. So the number of ways to choose k balls out of n to give to your friend is the same as the number of ways to choose the remaining, which is n minus k balls out of n to not give to your friend. Is there any question about whatever I just talked? Please make sure that you understood everything here because it's really basic compared to like some kind of question you get asked on the test. Okay. If there's no question, I will let you work on question 1, maybe 3 or 4 minutes. I will take this up 2:23. If you're still confused about anything I just talked, feel free to let me know. Okay, so first, since the question is asking for probability, we know that we have to find the cardinality of the simple space, right? By your common sense, you will see that you have to find the number of ways to choose 3 winners without any restriction. In here, we have 20 couples. 20 choose 3. We have 20 couples, right? Which means how many people do we have? It's pretty close. Yes, we have 40 people. 20 couple is equal to 40 people. Out of those, I have 20 men and 20 women, just because the question assumed that it is a man and woman couple. So which means out of 40 people, I can choose 3 to be the winners. So this would denote the number of ways I can choose 3 winners from 20 couples without any restriction. For the first one, I have the restriction that there are only women. So what is the number of ways to choose 3 winners such that all of them are women? How many ways I can choose like that? It just means I look at the woman and I choose them, right? I see a student answer here. 20 choose 3 and 20 choose 0. Yes, that is correct. The student got this number, I believe, because this one, out of 20 women, they choose 3 to be the winner. And out of 20 men, we choose 0 as the winner. Since all winners are women, so we have 0 men as the winner. So this would be the cardinality of the events where we have only women are the winner. But we are probability, so we have to divide it by 40, choose 3. Since we want probability. Second, we want 2 men and 1 woman. How many ways are there that I can form 3 winners such that 2 of them are men and 1 of them is a woman? Yes. So first, out of 20 men, we choose 2 to be the winner. And then out of 20 women, we choose 1 to be the winner. And we want probability. Again, we divide by 30, 40, choose 3. Last one, we want 20 choose 1 becomes 20, right? Yeah, because if you think of it, how many ways are there to choose 1 object out of 20 objects? There are only 20 possibilities to correspond to each object being chosen. You will see some important identities like n20 is equal to 1 because there is only 1 way to choose nothing out of n. Or like it is also equal to n choose n because out of n elements, how many ways are there to pick n elements? There is also only 1 way, which is to pick everything. And then you will have like n choose 1 is equal to n. Because you can have different possibilities correspond to each object being chosen. If we come back to this one, we want the restriction is there is no couple. For example, if you have 3 winners, and let's say we have a couple as men 1, woman 1, men 2, woman 2, something like that. The winner can be men 1, woman 1, and men 2, right? Then among the 3 winners, there is a couple. in this case, but we want no couple, which means we want the three winner comes from three distinct couples. What we can do is, first, out of 20 couples, I choose 3 couples. Why is that? Because we want no couples and we have 3 winner. Winner 1, winner 2, winner 3. There's no couple means that winner 1 comes from one couple. Woman 2 come from another couple. Woman 3 come from the third couple that is different from both 1 and 2. Which means out of 20 couples, I can choose 3 couples. And out of each couple, I choose 1 to be the winner because each couple have 2 people. So I first choose the winner from couple 1. And I choose the winner from couple 2. And I choose the winner from couple 3. And I divide it by 40, choose 3. Is there any question about what I did? Please make sure that everything makes sense.
I'm so sorry. Could you explain this
Yeah.
like one more time very quickly?
The third one?
Yeah, the third one.
Yes. Okay, so
Just
we
the
have
numerator.
yeah. We have 3 winner. Winner 1, winner 2, winner 3. Since there is no couple, the 3 winner have to belong to 3 distinct couples, right? The winner 1 must probably come from couple 1. Winner 2 can come from another couple that is different from couple 1. Winner 3 come from another couple that is different from both 1 and 2. So out of 20 couples, I choose 3 couples. And then once I got those 3 couples, for each couple, I choose who is the winner, the man or the woman. I do that for 3 couples. And after that, it means I would already formed the 3 winners. So these would be the number of ways such that I can form 3 winners and there's no couples in them. And I want probability, so I divide it by the total number of ways to choose 3 winner without any restriction. Yeah. If there is no question, I will let you work on question 2. Maybe 3 minutes again. Please let me know if you are confused about anything. Okay, so for this question, you have a group of 12 people and you want to form a committee of 5 people. But we have the restriction is that among the 12 people, there are 2 people do not agree to serve in the committee together. For example, you have these 2 people. If person 1 is in the committee, then person 2 will refuse to be in the committee with person 1. And if person 2 is in the committee, then person 1 will refuse to be in the committee with the person 2. So how many ways are there? We can form the committee. We have to do cases, right? Because it really depends. So it can be that none of the 2 people who do not agree to serve together, none of them are in the committee. Then how many ways this can be done? If we exclude those 2 people, we only have 10 people left. And we want to form a committee of 5. So we have 10 choose 5 ways for this to be done. Next, we have exactly 1 of the 2 people are in the committee. So out of the 2 people, we choose 1 to be in the committee. And then for other people, we only need to choose 4, right? So we kind of separate the 12 people into 2 groups. The group 1 is those people who do not agree to serve together. And then the rest of them, which is another 10 people. In the first case, we don't include anyone from the first group. So we choose all 5 people from the other 10. In the second case, we want exactly 1 of them to be in the committee. So we can pick 1 of them. And from the rest, from the remaining 10 people, we only pick 4 because we want a committee of size 5. So in total, we would have 10 choose 5 plus 2 choose 1 times 10 choose 4 ways. Is there any question about what I just did? If it makes sense, I will let you work on. Let's skip question 3 for now. If we have time, I will go over it. But other than that, I want to go over question 4 here. We want to give a combinatorial argument, which means I don't want you to expand any expression. Like I don't want you to write this down as some expression like this. I don't want to see this. No computation at all. I want you to show me that the left-hand side is equal to the right-hand side. I cover this question in 20101 with a different solution. For this tutorial, I will show you another way to solve it. But if you are interested, you're welcome to watch the recording for 0101. You might like that solution better. I feel like that solution was more intuitive. However, it is beneficial for you to see different kind of solution. So here, let's say, I also believe you covered this kind in the lecture. For example, you are starting at the point 0, 0, and you want to reach to the point NN, but you are only allowed to turn right or going upward. You have to go step by step, one unit at a time. Like from here, you cannot directly jump to here. You have to go either to the right or upward. And we are interested in how many ways are there? To travel from 0, 0 to the point NNN, if you are only allowed to go right or go up in each step. Did you cover this in lecture? We haven't seen this one because I saw it in like the lecture note, I believe. Not for today, but like even before the test. Okay, so I will talk briefly about this so you have time to think. One possible ways that we can travel from this point to this point is we go in this path like this, right? Let's say here I have 0, 1, 2, 3, 4, 5. Let's say I have 5 and 5 to be specific. We will have to generalize it for the point NN, but let's start with 5 and 5. If I go by this path, it is the same as I go right, and then I get here, and then I go right again, right, and right, like here. I go right, I go right, I go right, I go right, I go right 5 times, and then I hit this point, and then I just go up. How many times do I go up? I go up 1, 2, 3, 4, 5. I have to go up 5 times. So this is one possible ways to go from 0, 0 up to 5, 5. Another ways you can do is, let's say this path here, right? And what is this path? Is you go right, and then you go up, you get here, right? And then you go right up to, you hit the H, so you go right again 4 more times. And once you get here, you go up 4 more times. You will realize that no matter what path that you go, you will have to turn right exactly 5 times. And you will have to go up exactly 5 times. The difference is just the order in which, when do you turn right and when do you go up. So it's just the number of ways that you can arrange this sequence of characters. So maybe I will give you 5 minutes to think about this. I suggest you to start from the right-hand side. You should show at the right-hand side, count the number of ways that you can go from 0, 0 up to NN. And then after that, if you figure out the right-hand side, you can move on to the left-hand side, showing that the left-hand side also count the number of ways to go from 0, 0 to NN. And since the the left-hand side and right-hand side both count the same thing. Therefore, they have to be equal. So that would be the structure of our argument. I will take this up 350. Let me know if you are still confused about anything. Did anyone figure out the right-hand side? Like for example, if we work with concrete problem where we go from 0, 0 to 5 and 5, then the number of ways that you can go from here to here is that just the number of ways you can arrange this sequence, right? Because no matter path you do, even you go by this path like this, or you go something like this, you will always see that you have to go to the right exactly 5 times and go to the upward exactly 5 times. So it becomes a problem of you have 10 blank, and out of the 10 blank, you choose 5 spot to insert R. For example, if you choose these 5 spots to insert R, then it means that at those spot you turn right, and at the other spot you go upward. Then it would be something like this. So this problem, the number of ways to go from 0, 0 to 5, 5, where you can only go to the right or going up, the number of ways you can do that is 10 choose 5. Does this specific example make sense? If not, then you should let me know where it doesn't make sense. Yep, thank you. So if we generalize this from 0, 0 up to n, right? We have from 0, 0, this point here. We go up to n here. Then we will always have to go to the right exactly n times. And we have to go up exactly n times, which means our first answer can be out of n plus n position, which is 2n. We choose n positions to turn right. And then the remaining positions will be going up. So that is the first way we can answer this question, is 2n choose n. And we will show that the second way we can answer the question here. I will show that the second way I answer this is the left-hand side. And then since the left-hand side and the right-hand side both answer to the same question, they have to be equal. So how do we get a bunch of addition like this? It suggests us that we are dealing with the sum rule or addition rule, which means each of the number here counts some cases that are disjoint. I broke my problem of traveling from 0, 0 to n down into a bunch of disjoint cases. And for each case, this is the number of ways that you can complete that case. So how does this make sense? If you think about it, when you travel from 0, 0 to 5, 5, you will have to go through this point, or this point, or this point, or this, or this, or this. There is no way that you can travel from here to here without touching all of the point here. You will have to touch exactly one of them. Why exactly one? Because if you touch this point, you will not be able to touch this point because it requires you to go to the left, right? And we are only allowed to go right or up. If you touch this point, you cannot touch these 2 points because it requires going to the left. So we can say that to go from 0, 0 to 5, 5, there are 6 possible cases. The first case is you pass through this point. The second case is you pass through this point. The last case is you pass through this point. And then you will calculate the number of ways that you can perform each way. For example, how many ways are there? I can go from 0, 0 to 5, 5, such that I pass through the point 0, 5. Sorry, this is a point 0, 5. Okay. How many ways are there? I can travel from here to here, such that I have to pass through here. So I can calculate that by first traveling from 0, 0 to 0, 5. How many ways are there? I can travel from here to here, such that I only use turning right or going upward. You will see that from here to here, I will have to walk 5 steps. And out of those 5 steps, I choose 5 positions to turn up. Or you can also think of it as I choose 0 position to turn right. Because from here to here, you don't turn right at any time, right? They're exactly on top of each other. And after you go from 0, 0 to 0, 5, you will have to travel from 0, 5 up to 5, 5. And how many ways are there? I can go from 0, 5 to 5, 5. I will have to perform 5 steps in general. Again, I will have to go 5 steps to reach from here to here. And then I can choose 0 spot to go up. Or it is the same as I chose 5 spot to go right. So that is the first point. You will have to take any of the number on this part, multiply with any of the number here. So what I can do is going from 0, 0 up to 0, 5, and then from 0, 5, I go to 5, 5. From 0, 0 to 0, 5, I have 5 to 0 ways. From 0 to 5 to 5, 5, I also have 5 to 0 ways, which give me 5 to 0 square ways to go from 0, 0 to 5, 5 that pass through 0, 5. Does this step make sense? Yes. And the second case is I go from 0, 0 up to 1, 4. The point here is a point 1, 4. And then from 1, 4, I will go to 5, 5. First, I will check how many choices are there for me to go from 0, 0 up to 1, 4. To go from here to here, I will have to perform 5 steps. No matter which way I go, I will have to perform 5 steps. Out of those 5 steps, I choose 1 to be turning right. I can go turn right here, or I can go turn right here, or I can go turn right here. I can go turn right here, something like that. So out of the 5 steps, I chose 1 to turn right. And then from 1, 4 to 5, 5, I also have to perform 5 steps. Out of those 5 steps, I choose one to going up. For example, I go up here, or I can go up at here, or I can go up at here. Okay. And then the last one, if you do like that for every of the case in the diagonal like this, you will reach to the point where you reach the last one, 0, 0, go to 5, 0, and then go to 5, 5. This is a point 5, 0. Going from 0, 0 to 5, 0, I have to perform 5 steps. Out of the 5 steps, I chose 5 spots for turning right. From 5, 0 to 5, 5, I chose 5 steps for going up. So this will give me 5 choose 5 square. Okay. And this is the argument for a specific example. But we want to generalize for 0, 0 up to n. So we can use the same thing. It has to pass through some point on the diagonal. So for n, we will see that it has to pass through some point in the diagonal. You can use exactly this argument, but instead of 5, you use n. You will see that, okay, the first case is I pass through this point here, which is the point 0, n, right? And from 0, 0 to 0, n, I have to perform n step. Out of n step, I choose 0 step to turn right. And from 0, n to n, I also have to perform n step. Out of n step, I chose 0 step to go up. You can basically turn the number 5 into n. And 4 is just n minus 1. You can do like that, and it will give you the general argument. If you want to say it even more general, you can just say 0, 0, go to the point I, n minus I, which represents some point on the diagonal. And then from that point, you go to n, n. From 0, 0 to I, n minus I, we have to perform n steps. Out of those, we have to choose n to turn right. We have to choose I to turn right. And then from I, n minus I to the point n, we also have to perform n steps. And out of those n steps, we will have I step going upward. And then I can range from 0 up to n. And if you add everything together, you should get the left-hand side. And since they are counting the same problem, they have to be equal. I strongly suggest you to look at recording for TUT0101 because you might find that proof to be easier if you really don't feel comfortable working with this kind of path. We call it lattice path. But it's really nice to see that you have different ways to solve one problem. And for the last question, I will not go over it, but I will give you some hint. You can consider partition by the smallest or the largest element of the subset. Or if you want to do the lattice path again, you can consider the number of ways that you can go from 0, 0 up to the point k n minus k. So there are also again two approach for this problem. If you get stuck at any point, you can always ask on Piazza. If there is no question, I will end the tutorial today. I will see you on Wednesday. Have a good day, everyone.